Hello, welcome to a quick video on some area review, and we're also going to get into some 3D volume. So let's take it away. So there's a couple formulas that you're going to need in order to be able to calculate the volume of shapes. And so we're starting with area. And these shapes are in 2D if we're finding area, and if we're finding volume, they'd be in 3D. So again, this is just review. So just kind of follow along, try to remember some of these. Most of them, or all of them, you probably learned in middle school, but we don't expect you to remember that far back. So let's say you want to find the area of a rectangle. This one I know you learned in elementary school. So if I have a rectangle where I have all right angles, the area of a rectangle is just the length of the base times the height. You might also have seen this as length times width instead of base times height. Basically, you are just multiplying two of the sides together. So the area of a rectangle is just base times height. Easy peasy. Then, if you want the area of a triangle, you probably remember that that is 1/2 the area of the base times the height. So you can write this as 1/2 BH, or you could write it as base times height divided by 2. Now, I've got to be honest. I've seen so many people try to do base times height divided by 2 for a triangle and then forget the divided by 2 part. That I tell my students, try to remember your triangle formula like this, 1/2 base times height, because then the 1/2 is right out in front. You remember to do it every time, and you don't make a simple careless mistake. Okay, now, doesn't matter which one you use, but the area of a triangle is 1/2 base times height or base times height divided by 2. And then when we come over here to a parallelogram actually has the same area formula as a rectangle, and it's going to be base times height divided, not divided by 2, just base times height. So my pen won't let me erase here. So now when we come over to a parallelogram, the area of a parallelogram is actually the same as the area of a rectangle. It's just base times height. Except now we need to be more careful about what the height is. The height is always the perpendicular distance from the top of the shape to the bottom of the shape. Okay, in this triangle picture, it was clearly shown to us that this is the height. And in a parallelogram, it will also be clearly shown to us that the height is that perpendicular distance. You cannot use your slanty distance. That's not a height. That's a side length, not a height. Okay, so the area of a parallelogram is base times height, just like in a rectangle. And the reason that the area of a parallelogram is the same as the area of a rectangle is because I can chop off this triangle on the end right here and insert it over there. And if you look now, I have a rectangle with a base of this length, which is now up here, and a height that's the given height. Okay, I should have highlighted more of that. When I want to find the area of a parallelogram is base times height, just like the area of a rectangle. Except now we need to be more careful about what the height is. The height is this distance inside. It's that perpendicular distance inside the shape. And in fact, it's that perpendicular distance over here too with the triangle, where this is the height. Okay, so remember, whenever we say height, we mean the perpendicular distance inside the shape. Now over here we have base times height, which is the same as a rectangle. But wait, how can a parallelogram has the same area formula as a rectangle? They don't look the same. A parallelogram has these slanty sides on the left and on the right. Well, you know what? The reason it's the same is because what I can do is I can take this slanty piece over here, and if I shift it, bloop, It's that thing right there. And if we look, now what I've created is a rectangle where I've basically removed that right-hand side. This thing right here, I've removed it. I've plugged it in over here. And now I have a rectangle where this is the base and that's the height. All right. So now if we come down here, we've already talked about the area of a circle, and we've done so very recently. The area of a circle is pi r squared, pi times the radius squared. Now let's do some practice. So if I look at number 1, it tells us that it's a parallelogram, and the area of a parallelogram is the base times the height. The base is 20, the height is 12. Remember, the height is not the slanty side, it's the perpendicular distance. So the area of the parallelogram is 20 times 12, which is 240. Now let's talk about units. When I talk about area, I'm doing centimeters times centimeters. So I end up with square centimeters, and my computer freaked out. That should have been a 2. So square centimeters would be the units there. Now let's talk about this triangle. Whew, this triangle is a little crazy. So if I need base times height, the base would be this length right here. Okay, that's going to be a grand total of 7. And my height is this distance right here, which is 4. So the area of that triangle is 1/2 base times height. So 7 times 4 is 28. Half of that is 14. So my area would be 14. And my units are meters times meters, which is square meters. Okay. And then next, I have another triangle. Base times height. Okay, so my base is 7.5, and my height is right here. Darn it, they didn't give me the height this time. That's okay though, because in a triangle, you can turn it and make anything the base, anything you want. And if we turn this triangle, or actually just turn our head, what I can do with this is say, wait a second, I bet I could turn this triangle like that, so that the 4.5 is the base and the 6 is the height, because I already have a perpendicular. So what we're going to do with this triangle is say that its area is 1/2 4.5 times 6. So if I pull up my calculator and I do 1/2 times 4.5 times 6, I get 13.5. So this area is going to be 13.5 square yards. Okay. Circle. Area of a circle is pi r squared. So this is going to be pi times, oh, they tried to trick us. This 6 isn't the radius, that's the diameter. So my radius is 3. So this would be 1/2 of 3, pi, 1/2 pi times 3 squared. So pi times 9. And then usually we put that 9 out in front. So that's going to be 9 pi square meters. And then here's another triangle. We'll call this number 5. And if we look at this triangle, I need to do 1/2 base times height. Another little ambiguity here. Is the base this distance, or is the base just the 10? Well, since I want the area of this triangle, when I ask for the base, I mean the base of that triangle. So I only count the base side length, which is 10. So that 10 is really the only base that I want here. So when I do base times height, the base is 10 and the height is 6.4. This 4 feet is just an extra little piece. Now, this picture also goes to show you that the height of a triangle could technically be outside the triangle, because I want the perpendicular distance from the top to the bottom, and that's that 6.4. So 1/2, oh, pardon my yawn, base times height. And so that area is going to be 1/2 of 10 times 6.4. And that's 32. So 32 square feet. That's the review on area. Now we're going to keep going and do a super easy volume. And so down here, I have a box. The volume of a box is also something you learned in elementary school. It's length times width times height. Or really, when we talk about a box, it's just the three lengths multiplied together. All right, so length times width times height. So if I come down here to this box, the volume of this box is 10 times 3 times 4. And it doesn't matter what order you multiply in. Multiplication is commutative. So 10 times 3 is 30. 30 times 4 is 120. Now let's talk unit. Inches times inches times inches is cubic inches. And now I have my volume. And one more thing before we go, I am going to jump into what you need to do in Delta Math to get this to work out for you. It won't let me though. There we go. So if I want to jump into Delta Math now to show you what you're going to do, here's one thing that you're going to need to do. One of the questions is going to say, drag the yellow point until an accurate height of the triangle is drawn. Afterwards, fill out the empty boxes. Okay, so this is saying, is 6.17 really the height? No, because that's not a perpendicular distance. So I'm going to drag this until I get an appropriate perpendicular. Bing! I found it. Now that that's a right angle, this second step will open up. And now it says the length of the base is what? Well, the base is 4. The length of the height is, it's that 5.17. Therefore, the area of the triangle is 1/2 base times height, which is 10.34. And I'm going to submit my answer. Ta-da! Now, the other type of problem you're going to need to do, which is a little creative, is volume. So here's the volume of a box, okay? Now, we could just do 6 times 8 times 10 and get the volume, but we wanted to show you kind of visually what volume represents. Since volume is the region inside the shape, it's going to ask us, what are all of these things? So this right here is how many cubes? Well, that corresponds with the height of 6, so there's 6 cubes. Then if I press play again, it's going to fill the back wall. So that back wall would be the same as this front wall. So it would have a number of cubes. It's the same as the area of the front, which is 6 times 8, which is 48. And then it says press play again. And now we're going to fill it. And when we fill that up, now we have 6 times 8 times 10, which is 480. And if I press try, it says the volume is 480. I agree. And I got that one right. So that is what you are doing with area and volume this week. Good luck.